Hello, friend. This is Sanjeev Dwivedi, and on behalf of Vidyalankar Institute of Technology, I welcome you all in this Java session. In this session, we are going to talk about garbage collection. Now, garbage collection is one of the important feature of Java. Now, what happens in C++? Uh, whenever we have an object which is no longer needed, we need to and if it is created at runtime. Now what happened in C, runtime memory is allocated using malloc or calloc. Now such memory has to be removed using free function. Now what happens in C++, if I'm assigning memory at runtime using new operator, then I have to explicitly remove it using delete operator. Now, what do you mean by that? It means that the application developer, along with creating the application, has to take care about memory management. It is not a good job. It is not a good thing to do, because we want the application developer to focus on developing an application and not to take care about memory management. So Java frees the developer from this unnecessary burden. Now, what happens in Java, there is a mechanism called as automatic garbage collection. Now, what it does is, it maintains reference of any memory. Now, when I say reference, it means name. Now, let me explain you this. Now, let me explain you this. Now, if there is a class A, correct, and if we create object a1 equals to new A. Now, what it means, there is a memory, okay, and this memory is referred by reference A1. So, like we already discussed, this is my object and this is reference to the object. Now, if suppose next line I write something like this, new A, and I again make A1 refer to the object. Now what will happen is, there will be another memory. The A1 which is right now referring to this memory will now refer to this memory. So now we have this memory that does not have any reference. So it is no reference. So once it does not have any reference, my system will treat it as garbage. Now such memory has to be regained because it is unnecessary occupying space and it is of no use to us. Such memory has to be regained and user doesn't have to take care about that. It is taken care by system and a mechanism known as automatic garbage collection. So let's see how it works. Now, it is a process in which the memory allotted to the object which is no longer in use can be freed, and that memory can be used for other purpose. Now, garbage collection is it's basically a subroutine that runs periodically and keeps on checking if there is any memory which has no reference, or if my system is shortage of some memory. अगर मेरे system में memory कम है, then the automatic garbage collector will try to feed such memory and make the memory allotted, make the memory available to my system. So a garbage collector runs synchronously when a system memory, or asynchronously when a system is idle. Now Java, the garbage collection is performed automatically, so it optimizes the memory management. Now जैसे मैंने कहा कि it can be, it is basically, it's a subroutine that runs periodically, but can user explicitly invoke it? Yes, you can invoke it using system.gc method. So this will call the garbage collector. Now, like the way I demonstrated, suppose we have public class A is a constructor that initializes P to 0. Now, if I'm now suppose, now see, A1 equals to new A. So we have an object, A1 refers to the object. Then A2 equals to new A. We have object, A2 refers to the object. And if I say A1 equals to A2, means A1 will now refer to the memory referred by A2 only. So A1 and A2 basically refers to the same memory. So basically now this is memory that does not have any reference. This memory has to be removed explicitly. Now this is done by garbage collector. Now, In C++, there was something called as destructor. Now, destructor, there is a myth that destructor destroys the object. Sorry, destructor does not destroy the object. Destructor is called just before the object is supposed to be destroyed. So basically, if a destructor is called, it means that now you have an hint, you have an indication that your object is about to be destroyed. Now, what was special about destructor is, now suppose if my object is holding some non-programming resources. Okay, so let's say some data, suppose my object is binding to some database and my object is getting deleted abruptly. Now, what what will happen is, since the object is binded to some non-programming resources, when my object is killed abruptly, it may cause inconsistency in the resources it is binded to. So the ideal case is, if an object is about to be deleted, then all the resources held by the object should be removed. And this is what the ideal job of a destructor is. Normally, a destructor contains resource releasing code. So what happens in C++, destructor wasn't built again. So if the control moves out of a particular scope, now if you have a pair of curly bracket, opening curly bracket, closing curly bracket, and if the control moves out of closing curly bracket, then all the object created within this pair of brackets should be deleted. Correct? Now, for every object, destructor was called. Now, in Java, we do not have support for destructor function. Here we have finalized method. So what does finalized method contains? Now, if your object is supposed to be destroyed, user wants certain action to be performed when an object is supposed to be destroyed. It means that, let's say, if an object is holding database, then before the object is deleted, the connection with the database should be removed and the database should be saved. Now, suppose these are two steps that we want to perform. So we can specify these two code. We can specify codes for these action in finalized method. So here we have, sometime an object will need to perform some action when it is destroyed. For example, if object is holding some non-Java resources, let's say file or any window character font, then before the object is garbage collected or destroyed, these resources should be freed. To handle such situation, Java provides a mechanism called as finalization. So it's like finalization basically specifies the action to be taken. Now, this is how it is. A Java runtime calls this method whenever an object is about to be recycled. Inside the finalized method, the action that are performed before an object is destroyed can be defined. Now, the general structure for finalized method is like this: protected, void, finalized. The access specifier for the finalized method is protected, which means that it cannot be directly made accessible to the subclass. So this is about finalized method and garbage collection in Java. It actually reduces the job of application developer, so that application developer does not have to explicitly manage the memory. Thank you. This is about garbage collection.